Hello again. We just keep meeting like this, don't we? 2.4% equations lesson 2. I know you're on the edge of your seat. This is exciting business. So let's get to it. We're going to talk about percent applications. This section really deals with how we use percents to solve problems. Your two big steps here are going to be to take this word problem and translate it into some kind of equation. And then, of course, once you have an equation, you can't help yourself. You're just so excited. You really, really want to solve it. But before we actually get into the word problems, I want to talk about what 100% means. If we think of 100% of the students, we're talking about everyone, right? If we think of, I don't know, 100% basically represents the whole, or everything, or everyone. It represents everything in question, right? Everyone, everything, a whole. All right. We're going to need to review operations with decimals. Now, I think I'm going to include this video, so you should be familiar with this phrase. For adding and subtracting decimals, you line up the dot and give it all you got. Brought to us by our favorite rapper, TRM. So for example, let's suppose you had 2.1 plus 7 plus 8.15. A lot of people might be tempted to take 8.15, 2.1, and 7 and add them. This isn't going to work, and the reason why this isn't going to work is because you would be adding the hundredths place with the tenths place with the ones place. These have different values, right? You would never take $8.15 and say that you would add 7 pennies if there was no decimal out front. You would add the 8 and the 7. So instead what you should do is write it like this: 8.15, 2.1, 7, and we are going to add this. Notice the key here is that all of our decimals are lined up. Now there's no decimal point that you can see for 7. It's implied that it goes behind it. This one is bad. This one is good. Line up the dot, give it all you got. And then what I like to do to just kind of fill in the gaps here is put these zeros, so that way I can see that this is 5 plus 0 plus 0, which is 5. 1 plus 1 plus 0, which is 2. We have our decimals still lined up. And then 8 plus 2 plus 7 is 17. Again, adding and subtracting, you're going to line up the dot, give it all you got. Let's see, multiply. When you multiply decimals, what you're going to do is multiply the actual numbers themselves, and then you're going to count the number of scoops. And you're going to move the decimal that many times to the left. Okay, multiply your numbers. Count your scoops. And you're going to move the decimal that many times going to the left. So suppose I have 1.23 times 0.2. there is no need to line up the decimal for multiplication. You only line up the decimal for addition and subtraction. 2 times 3 is 6, 2 times 2 is 4, 2 times 1 is 2. And I count my scoops. I have, this is 1 scoop, 2 scoops, 3 scoops. And what I'm really doing is I'm counting the number of digits past the decimal. I have 1, 2, 3 digits past the decimal. When I write my final answer, it's going to be the same thing. I have 1, 2, 3 digits past the decimal. My answer is 0.246. Now, those of you going into allied health, the sciences, they really, really like you to put that 0 there. So I have a tendency to forget it, but I need to get better about that, so I'm going to work on that. I'd like you to do the same. Dividing. We have 2 options here. When you're dividing decimals, you can either do some long division, or you can write it as a fraction and reduce if possible. So suppose I have 8.64 divided by 0.2. Oh, I did it. Shoot. Divided by 0.2. Hello. There we go. That's better. 2 options. Option 1 is going to be to write it as a fraction. 8.64 divided by 0.2. Now, I need to get rid of the decimals and the fractions. It's creepy, right? We don't want to mix them. It's like elephants and hanging out with, I don't know, something that's not an elephant. They don't do it. That's a terrible example. Forgive me. I'm tired. Okay. I digress. We want to get rid of these decimals. I notice I have 2 digits past the decimal, 1 digit past the decimal. The thing that lets me move this is, if I need to move it 2 spaces, I really need to multiply by 100 over 100, right? If I multiply by 100 over 100, that's going to pull this 2 scoops to the right, 2 scoops to the right. What I get then is 864 divided by 20. At this point, I'm going to reduce the fraction. I look at this and I see that they're both divisible by 4, so I would divide the numerator and denominator by 4, but that's not what we need to be spending our time on, so at this point I'm just going to stop. The other way is to do some long division. I have 0.2 outside the house. I have 8.64 inside the house. But we don't want this number outside the house to have a decimal. So what we're going to do is, if I pull this in 1, I'm going to pull this in 1, and my new decimal is between the 6 and the 4. So what I'm really doing then is I'm dividing 2 into 86.4, and my decimal is there. Again, we're not, well, no, I can do this. 2 goes into 8 4 times. No, I don't want to do it. No, I'll do it. Okay, there we go. Our answer is 43.2. How great is that? Okay. So those are the 2 options for dividing decimals. Either go as a fraction and get rid of the decimals because we don't like to mix them, or do some long division, but make sure you don't have any decimals outside the house. Can't have that. Let's go ahead and do an example. Probably a good idea to pause at this point and just read this. In a study of 300 pregnant women with good to excellent diets, 95% had babies in good or excellent health. So here's what I see. I see the 95%, right? I know that this is 95 over 100. Anything else in here stand out? We're probably going to have to use the number 300. Most likely. Now, question A says, how many women in this group had babies in good or excellent health? Now, we know that 95% of them had babies in good to excellent health. So then the question becomes, what is 95% of 300? And I really recommend rephrasing the question. What is 95% of 300? The reason why I recommend rewriting the sentence is because we can now diagram it, right? I know that is means equals. I know 95% is 95 over 100. I know that of means multiply. I know that this is 300. And what? That's the thing I'm trying to find. Let's call that x. Another way to work this out is to think of proportions. Now, those of you who have a strong Math 90 background should be comfortable with the proportions because there was a fair amount covered during that. We can think, and you would solve this equation, I'm not going to. We can think of it as part over whole equals percent over 100, right? Because 95% tells me that 95 out of 100 women have healthy babies. So this is going to be 95 out of 100. And then we ask ourselves, we look at that second number and we say, okay, 300, is that the part or the whole? Well, that's the whole. Which means x would be the part that we're trying to find, the number of women out of 300 that had healthy babies. And at this point, with the proportion, what I would do is I would multiply both sides by 300 and simplify this business on the right. Again, I'm not going to do it because that's not a good use of time, in my opinion. You can do that. We should be fine there. Your answer, actually, let me have you finish this on your own time. Your answer is 285 is what you should end up with. 285 women. If we look at B, how many women in this group did not have babies in good to excellent health? Well, if 285 women had healthy babies, then that would leave 15 women that did not have healthy babies. So we would take the 300 minus the 285, would be 15 women. All right, let's do the next one. No, flip your paper. You guys can do this one. Don't you? Yeah, you can do that one. Let's go to the back side. And let's do this example down here. Tyler left a $4 tip. Okay, so we're going to do that example together. Tyler left a $4 tip for a meal that cost $25. What percent of the cost of the meal was the tip? So I look at this. I really like proportions. I'm a big fan of them. What percent? That's the thing we're trying to find. That tells me that I'm going to have x over 100 for my percent piece. Equals, we need part over whole, right? What percent of the cost of the meal was the tip? Well, how much did the meal cost? The meal cost $25. Ask yourself, $25, is that the part or the whole? It turns out that that's the whole. And then the $4 tip, that's the part. So I can set up my proportion like this. X over 100 equals 4 over 25. I'm doing the part out of 100, the percentage out of 100 that represents the part that was the tip out of the whole bill, or out of the whole cost of the meal. And then to solve this, I multiply both sides by what? I multiply both sides by 100. 100 over 1 specifically. On the left, my hundreds cancel, leaving me with x. On the right, I can reduce 25 and 100. 25 goes into both. 25 goes into 100 4 times. I end up with 16. 16 what, though? And then that's where you go back to your question. You say, okay, what was I really trying to find? You were trying to find what percent. So your answer should be 16%. And then check your answer and make sure it's reasonable. Is 16% a reasonable tip? Yeah. So probably your work was done correctly. And it was my work, so I could vouch that, yeah, it was done correctly. The example on the right here. Hit pause really quick and read that. Okay, you should have read it by now. I want to just point out something. This $477, that was an overpayment, right? It says the bill incorrectly included a sales tax of 6%. So if we look at the cost of what the bill should have been, and we add to that the tax, the cost represents 100% of what the school group should have paid, plus the tax was an additional 6%. So what we're looking at, this $477, the $477 corresponds to 106% that was paid. So when we set up our proportion in this case, we have part over whole equals percent over 100. And the percent is the 106, the overpayment out of 100. The 477 represents the part that was paid. Now this is a little bit backwards, but they paid more than they should have. They paid a larger part than they should have. So what we're trying to find is what the whole thing should have been. How much should they have paid? This one's a little bit tricky, but what we can do here, if we're solving proportions, remember you can do anything you want to an equation as long as you do it to both sides. So what I'm going to do is I'm going to take the reciprocal of both sides of this equation, and I'm going to rewrite it so that this x is in the numerator. Remember, the x corresponds to 100% of the bill. The 477 corresponds to 106% of the bill. So now I've taken the reciprocal of both sides. I'm going to solve this. I multiply both sides by 477 over 1, 477 over 1. My 477s cancel, and I get that x equals whatever this is. I'm not going to finish it because the setup is the thing that really matters here. And yeah. All right, so what I need from you. I would like you to do the warm-up here. This is a really good review. This is good stuff to keep practicing. This comes out of Chapter 1. Solve for y, that was the section 2.3 on formulas. You're going to isolate the y. And then these come out of percent equations lesson 1. You should have covered this in the video just prior to this one. And then we have 1, 2, 3 and a half problems. So go ahead and finish the rest of the problems on this page before coming to class. Thank you. This has been a lot of fun, and I'll see you soon. Bye.